Hi everyone, this is Rahul. So let us wait for a couple of minutes. We will wait for a few other participants and then we can start with the webinar. So I think we can start now. So let me share my screen with you. So I am Rahul Rai. I have graduated from IIT Kharagpur in 2007, post which I have worked with companies like Cognizant, Bank of America, ICICI Bank. I have been associated with Transorg Analytics for more than 3.5 years. For last 12, 13 years, I have been working in the field of advanced analytics, machine learning, and AI. So today's agenda is divided into two main domains. At first, we would cover the meaning of data science, the timelines, and associated fields. In the next section, which I hope the audience will find interesting, we would be covering few of the main themes, or let us say current trends in analytics. And when I say current trends, the worldwide trends that might be happening in analytics and how it is surely and swiftly changing the world around us. I will try to keep the second section interesting and anecdotal. We would talk less about theory and more about facts, which got covered in news or research articles, acting as our evidences. And I hope to finish this webinar in 1 hour. We will also be having a Q&A session once I have completed the webinar. So moving on to next slide. So here we will be discussing the technical jargons associated with data science. So this is a typical data science type timeline, and if you Google, you would find similar timelines representing how AI is not new and how it has evolved. But let me try to make it more interesting for you. So these are few words, few jargons that are associated with data science, and the journey for data science, I would say, started with mechanization. And as you can see from timeline, it was around, it's written 1950. I consider it, I mean, a century before, or maybe 2 or 3 centuries before. So mechanization, I would say, like when humans started building tools which might help them do their work efficiently. So a simple hammer or sickle can be seen as an example of mechanization. So when I started my career, all these words are pretty confusing. Like people talk about machine learning, data science, decision science, AI, and I was not pretty sure that like how do they converge into one topic. So let us start with an example of a traffic light. So one day, let's say as a human civilization, what we discovered was that a vehicle stopped to red and move at green and installed a traffic light at an intersection. And you programmed it so that after certain intervals, the color of the light changes. Now you can call this system as somewhat intelligent, as it knows about how much time it has to take before turning to a different color. So while we have reached the domain of AI, machine learning and deep learning are still far away right now. Now what happens is that the traffic policeman who is who is seeing that traffic light after some observation realizes that, well, this regular changes do not help much. We need to do an update. So what he actually sees is that the traffic increases significantly around 2 o'clock as there is a school in a vicinity, while it dwindles down to a few vehicles during night. So at different time period, you might need different intervals at which the light changes to red or green. So based on the time of the day, he tries to program that light to change color. So if you are following my story, what is happening? We have introduced one more variable to the universe. There is one more input variable which is affecting your output. Then with time, what he realizes is there are other variables as well. There are office hours, traffic jams at other intersections, accidents in nearby vicinity, whether it is raining or not, festivals, etc. So as and when he keeps on adding a variable to his data universe, which keeps on making his model more robust. And what is the model predicting? How much traffic will I get in next hour, minute, or second based on how granular my data is? So now we have entered the domain of predictive analytics, where the traffic policeman, based on that, okay, this is the amount of traffic I will receive in the next hour. He tries to program his light. And then one day, what happens? Let's say a policeman senior comes and he says that it's a very good technology, very new technology, and he wants to incorporate that at different intersections. But what he says is that you know what, we have a new camera system as well, so it converts images into readable formats and gives you an idea of the density of the traffic. So now you integrate that system to your traffic light, and the light starts using the model you had developed plus the real-time traffic density to change colors. But then there are errors in prediction. Now, obviously, none of you won't be receiving, whenever you start your career in data science, it is very difficult to receive 100% accuracy for your models. There will be errors in prediction. Sometimes jam might happen, even though your input suggests that it won't be happening. You enter into those predictions again, those errorful predictions, and the signal tries to adjust the parameters over it. So parameters or weightages. So suppose there is X amount of weightage you gave to the time to the afternoon. Based on the weightage, the light is changing, but it is also learning how to change in future based on that weightage. So it tries to play around with those weightages. Right. So it's a kind of feedback loop, like you have tried to use those errors to predict better in future. And this is how machine learning starts happening. So machine is learning on itself at this point of time. The next domain we can foray into is deep learning. So which is nothing. I mean, that also makes a machine learn, but it makes your statistical model more complex. So by more complex, I mean more difficult for a human to understand, but maybe easier for a machine. So your input remains the same, but your model might now be based on, say, a neural network. So to summarize, data science is sum total of what all I said regarding this traffic light. It encapsulates the intelligent components of the AI and covers the ML and deep learning components as well. I mean, there are other words mentioned on this slide, as you can see, like business intelligence, BI, data visualization, which are again part of it. They are related to it and help us in presenting our data in business readable formats. So while a lot of you might be looking to start your career in data science, that is why I'm stressing so much on what data science actually means. And the easy way to understand this word, or the words I said, machine learning, deep learning, etc., is to just divide that word into two. So data science comprises of data and science. So for a data scientist, data and science both are equally important. Your scientific or statistical models are only good as your data. And this brings us to the current fallacy that a lot of people, when they start their career in data science, they suffer from, and I want you people to guard yourself against it, is that at the start of your career, they pay a lot of attention to science, building complex models rather than the data itself, the business that is generating that all that data. So my suggestion to anyone who is looking forward to start on this journey is to try to get a good sense of data first, like how the business is collecting the data, what might be the gaps in terms of data collection, how this data is related to each other. And then once you have invested sufficient time into this, then you start running different models. And running models is becoming easier every year. So the idea is, the more business and understanding you develop of the domain, the better data scientist you would become in your future. I mean, models are still a function of data. They are not as intelligent as humans. You put in garbage, you will get out garbage. So business understanding is a necessity for a data scientist worth his salt. So the idea of today's lecture is if you can see the topics, job prospects, etc. I think in previous webinars as well, people might have covered this topic. My idea is to give you a overall worldwide view that because a lot of you might be looking to start a career, you would like to stay invested for next 5, 10, 15 years. I mean, that is what career means. So I would like to give you a worldwide view that this is a kind of domain which we do not see that it will, vanish in say next 2, 3 years, but vanish, not even vanish, it might keep on growing to, I don't know, do not, I mean, I can't put a number, but the size and the scale at which it is growing currently is pretty humongous. So the first is let me try to address the elephant in the room. What are the job prospects? And for this, I have taken the China case study. So on this slide, what you see are some of the graphs related to AI industry in China, but this is more or less a worldwide phenomenon. You can see how the investments in terms of in AI are increasing every year, and what is the market size that is increasing for here. And there is a widening belief in academic circles that the technology is saving China's economy from slowing down. So if you, I mean, if you people were following any news, so what happened in 2014 or 15, there were a lot of news that China economy is slowing down. There were news about unused ports and ghost towns where no one was living in these skyrocketing flats and apartments. And then there was an impetus from the government towards adoption of technology and AI that helped China get out of that slowdown. In 2017, as you can see from the table in the middle, AI became part of the national strategy document in China. And now its companies are a huge competition to its Western counterparts. You might have seen videos about how China has a humongous face recognition system, and how even in today's time, in times of COVID, an app decides if you are healthy enough to enter a mall or a restaurant. such transformations are happening across the world, and it is a very good time to be part of the data science workforce. So if you can see, like, year on year, there's almost, I would say, 20 to 40% increase in terms of investment and in terms of market size of AI. AI is a domain in itself. It is developing as a domain in itself. Like we how we talk about, say, banking, real estate, etc. What we foresee is that AI might become a domain in itself in next 5 to 10 years. So job prospect was the first one. This is the second phenomena which is happening currently, and that is about data consolidation and aggregation. So are you able to recognize the graph which is shown on the this slide? So if investments are taken to be 100%, this is the share of investments done by different organizations in geo platforms, which was a recent news. So why do you think that Facebook, like, out of that 100%, Facebook took 30% and Google took 23%? I mean, leave out the market potential and the fact that Geo has increased its subscriber base at a very good pace in last years. It has a huge repository of data. I mean, Facebook and Google are organizations built on data. Knowing what I browse, which sites I spend on, what I watch, helps them in segmenting me to a group and targeting me with business campaigns. So this is the kind of data consolidation which is happening across the world. I mean, imagine what kind of data Google might have for you or Facebook might have for you. So for every individual, I mean 6 or 7 billion population, these companies have humongous amount of data, and which is getting processed at I mean a very, I mean, lightning speed. Another example of, I would say, data aggregation is the movement from our old televisions to smart TVs and OTT platforms like Amazon Prime and Netflix. So the story here is again is data aggregation. I mean, I'm not talking about technology. Obviously, the technology improved. Your TV, your televisions got, smaller in size, smaller in width, etc. But how the data aggregation is helping such companies? I mean, what that is the prime objective why there is so much push into technology right now. So earlier, you must have heard about TRPs, right? Program and channel TRPs. So does anyone knows how it is collected? I mean, so in short, there is a sample population and a device is fitted for a
Hi, this is Amit, the host of this webinar. I think Rahul is having some problem at his end for his internet connection. Let's wait for a minute for him to get back online again. Thank you.
Hi. So can everyone hear me? Sorry, there was a power cut at my location.
Thanks, Rahul. You are very much audible, and I had requested the audience to be patient in the meanwhile. So good that you are back. Let's resume.
Yeah, sorry for that. So I'll just continue with my presentation. Thanks, Amit. So yeah, so I was talking about the OTTs, right? So what is happening right now is that data consolidation, which is happening at a very rapid pace, and like the TRPs, which were collected based on that, there was a box which was placed in at a sample population, and it gave you that, okay, 20% of my sample watches this program, etc. And based on that, advertisers try to contact the channel or the programs. But now with Netflix, like almost everything is getting personalized, right? Like what you search, what you have seen, etc. So everybody knows that, and it is easier to understand our likings based on the OTT platforms that we are using. Another theme, I won't be talking about it much, but another theme which is happening is data localization. So government want to keep the data in their territory, etc. But on a larger scale, whatever happens, it would eventually help people working in this field. I mean, consolidation would lead to more capital, meaning higher salaries. Localization would lead to more jobs. So a win-win for us in both cases. So now let us move on to process automation, which again is happening at a very large scale, and data scientists uh, are a lot of help in terms of removing inefficiencies and streamlining it. So on this slide, we have mentioned certain areas and related use cases where businesses are foraying in. So for example, social media data integration. So data from Facebook, Google getting integrated for your organization. So if you want to measure the success of your digital campaigns, what is the pulse of my customer? Data extraction from scanned documents, insurance agencies who want to automate their KYC process, like know your customer processes. So every time you go to a bank, you give your Aadhaar card, PAN card, etc., and there's a person who verifies it. So rather than having a person maybe automate that whole tedious process, and then the automated hotel check-ins, uh, NLP and conversational AI, and I will again come back to it, like chatbots. So right now there is a customer care service which works for you for different organizations. But what about chatbots? Like there's a conversational AI which is talking to you, giving solution to your problems, etc. Video and image analytics. Again, logo visibility during an sports event. So suppose an IPL match is going on and you want to see that, okay, I was the title sponsor, I being Paytm was the title sponsor, and I want to see that for how many hours my logo was visible on the TV screen. So basically you can do it using data science. Again, speech analytics, like conversion of my speech to text. I am talking to you in this forum, and suppose Amit wants to take the next presentation, then the whole of my speech gets converted into text and is given to him. So things like that. So just to showcase how far we have moved into this area. So one case study is Amazon Go, and you might have saw the video on YouTube. It's a fully automated retail store which can work without presence of a personnel. The multiple cameras do face and object detection. Focusing on an object might tell you about its information, and you can check out using your mobile. It is one of the highest level of automation we have achieved in present. And on the left side is one of the chatbots that Facebook had created. The story about the chatbots Facebook had created. So I would like you to Google about it and understand how far AI has moved. So basically, what happened here was that Facebook was creating its own chatbot, seeing that whether if they can be used to solve customer problems, etc. And they decided, let's allow two chatbots to converse with each other and see how accurate they are. So what happened a long time was that while those chatbots started getting trained, so what happens is that whatever you say to a chatbot, right, becomes an input. So based on that input, I can give that, okay, this is the correct output for it. So with time, the bot learns. So while this bot kept on learning, what happened was they actually created a language of their own to talk to each other. And that's why Facebook had to shut down these chatbots, because they couldn't understand what they were talking about. So they shut it down. So this is how far this field has reached. And I mean, and people think about that, what if automation happens and everything gets automated, what about us, etc. But point is that automation is a never ending field. I mean, uh, take an example of whatever city you are living in, or whatever metro you might be living in right now, or whatever metro you might have seen in your lifetime in India. I have been living in Gurgaon for 12-13 years. It keeps on developing. There are new roads, there are new malls coming up, new residential apartments. So automation is a never ending phenomena. For example, let me take an example of smart cities. Like a smart city has been India government's project since, I do not know, maybe 2009, 2004, etc. Uh, there are, I mean, consider a timeline of next 30-40 years, right? I mean, there would be 20-40, I do not know, maybe 60 different cities in India which need to become smart. And it will be the technology workforce, or the, I would say, AI workforce, which will give fodder to those cities. From smart homes to smart cities, there are multiple problems that need to be solved in current era. So the next thread I want to discuss is how data science is improving lives around us, right? I mean, uh, uh, I developed this slide based on my own personal experience. I mean, I am very bad at remembering directions. So Google developed map for my kind of people. As more and more people buy Android phones, the maps are getting more accurate. So it's better for me. Imagine the amount of data Google might be processing every second. Like, for every nook and corner of the world, it looks at how many mobile phones are currently moving around, right? And tries to predict the time from destination A to destination B. So starting from feeding in the data, right? Like Rahul lives in, say, this vicinity of Gurgaon, etc., to creating a path from Rahul's destination to his office. There are so many vehicles around. There are so many, I would say, variables to play around with, and still Google, the time Google predicts is pretty accurate. And the another one is e-commerce. Like, e-commerce became a positive possibility because they converted the word of mouth to customer reviews. I mean, uh, I would say that maybe 90% of you are now might have used e-commerce till now, or more than that, maybe 100%. So you might not have bought a lot of products which do not have any customer reviews, right? So that is how analytics helps. Like, how many, if you can rate the item, how many people rated that item as 5 star, what are the features on which the items are getting rated, what people are talking about those features. So you can create different NLP algorithms around it and give a better view of the product to the customer. And then in this thread only, let us move to a more futuristic thing. I mean, so let me talk about something more exciting, and you might have, if you are following the AI news, etc., you might have heard about it: driverless cars. Uh, so again, a set of highly sophisticated camera system is doing the trick for you. So the car knows that there is a stationary or moving obstacle in its front, and whether it needs to accelerate or wait based on it. But that is all right. I mean, you have cameras, you can identify, okay, there is an obstacle, let's apply a brake, or there is a moving obstacle and I do not need to apply brakes as it will cross before I reach that place, etc. So that is programmable. But consider all these kind of questions which are happening, like what I am trying to show on the right side of the slide, that how do you know that given two choices, right? I mean, when the accident is inevitable, the accident is bound to happen, whether to save an old lady or a child. I mean, there is an old lady on the road, there is a child on the road, and you do not have a choice. I mean, these are two choices you have. So, where, I mean, whether it you will try to bump into the old lady or the child. So again, consider this, that whether given two choices, whether you will try to save a pedestrian or the person sitting in the car itself. Like, your car is moving, there is suddenly a pedestrian appears, so whether you will maneuver to uh, your car and put your life in danger, or you might hit the pedestrian himself. So these are pretty ethical questions which data scientists have faced. And these questions, as I'm saying it, these questions were not thought about that much once we were, infancy in building these driverless cars. But now these questions are becoming more and more important. And again, people are resorting to data science and analytics to answer that. And how that is happening, I mean, so there is something called, what I can say is herd analytics. So what I do is I bring, say, 30, 40, 100, or maybe 1,000 people of my community to a room, and I ask them same questions, like whether you will try to save the old lady or a child. And based on their answers, like what the majority is marking as the answer, and these questions become difficult. Consider of, I mean, there could be multiple scenarios, right? I mean, whether to choose between killing 2%, 3%, etc., etc. So there could be multiple scenarios. So I try to make them answer those questions, and based on that, I try to program my cars. And still, this is getting worked out, because you are trying to put one life above other, etc. At different societies might be having different norms. So it's still a question which is unanswered till now, but people are getting to it, and data science is helping them getting those answers. So moving to the present times, and this is the last thread I'll be covering in today's talk. So the idea of all this thread, which I tried to cover today, was to give you a flavor of why data science is going to be important as years go by. Right now, it is a rising industry. At some point of time, it might get saturated, as people, as we have seen other industries. But what we foresee is this is not happening in next 10, 20, or 30 years. Maybe when you are past your retirement age, then these things might happen. But AI and data science will remain a lucrative career for times to come. In terms of how many people it can absorb, etc. I mean, we cannot, again, we cannot put a number to it, because considering the amount of investments and the way the market is growing for AI industry across the world. I mean, it is happening in India, it is happening in China, it is happening in Western countries, everywhere. Things are getting automated, things are getting, processes are getting eliminated. I mean, a lot of processes. And then there are people, who are putting a lot of effort in how to reach my customer. I mean, who my customer is, how to reach them, how to reach them in a better way. So all these things are being worked out in almost every organization, every big and small organizations across the world. So, and we do not see that trend fading out. It's a pretty new trend to start with. I mean, uh, I have 12 or 13 years of experience in this industry. I have seen things how they have changed in past few years. Uh, the space is rapid. The learning you will get out of it would be, I mean, it would be, it keeps on changing, and there are new problems to be solved every day. So you would absolutely love it to be, part of this AI journey. And this is the last case study, and why I included it was, I mean, because of present times. And so fraud is one of the things that, I mean, that pesters businesses a lot in today's times. And what happens during these kind of times when the job opportunities become bleak, or I would say uh, economy might be put into recession, etc. Those are the kind of news that are floating around, that frauds increase. I mean, let us discuss the post-COVID era. Uh, what will happen is, like, if suppose recession happens, it would mean slowing of businesses, shuffling and reskilling of people, and a burst of economic activities post it. I mean, people hit hard by this recession, etc., might find it easier to resort to unscrupulous method to cheat the system. And that is why the fraud systems across the world are being tried to become robust, etc. And I've also included a recent study by RBI, and what they have seen is there is a year-on-year growth of 74% in terms of fraudulent cases. So 74% seems like a big number. It is lower than how the AI is growing. So we can always catch fraud if we try to use AI to catch it. And in terms of value, we have seen an increase by around 50% year on year. And just to give you a flavor of few of the models, I won't be getting into nitty-gritties, but just to give you the kind of models we run. So basically, there are two ways to solve fraud, and there are multiple other ways, but I will be covering these two ways. So the first one is isolation forest, and you can understand it by saying that, suppose I have 100 variables for a particular person, right? And I have, say, a population of 1,000, 2,000, or 10,000 people. A person who is a fraudulent customer, or say an individual, there might be one or two variables which might be outlier for him. And the idea of isolation forest is to catch those variables. So because those variables are outliers, and when I say outliers, I'm talking about multi-dimensional outliers, like he might be outlier in 2 or 3 of variables out of 100, etc. So isolation forest works on that premise, that if a person is outlier, it might be easier to catch him if I try to create a tree out of those variables. Like, he will be the first one to catch before we catch other people. So that is one. Another technique which is used is autoencoder, and this autoencoder is again part of the deep learning, because I mean, it's a neural network technique. So again, what you see, the input layer is larger than the internal layers and the output layers. So what it is actually doing is, it is trying to compress the inputs. So when I say compress, it is trying to identify what are those most significant features which define my population. So it compresses the input, identifies those features, and then it tries to create a mirror image of that input based on the features it has learned. So obviously output won't be equal to input, but it will be closer to that. And the more you are away from those identified significant features, the more you will be an outlier, more you will be a fraudster, etc. So, and as I am talking to you, a lot of research is going into this fraudulent customer identification or fraudulent transaction identification, etc. And there are, again, as I said, that technology keeps on improving on itself. So there might be some new methods which might come in near future, which will help us identify frauds better. And let me talk about one of the exciting use cases of auto encoder. So it helps you convert the images which you might have clicked, say, using a very high resolution camera or an iPhone, to WhatsApp forwardable images. What would you might have noticed that WhatsApp compresses those images and sends to your contacts. So what again is happening here is that for every image, it goes through, and I'm not saying that this is the algorithm that WhatsApp or iPhone might be using, but you can use that algorithm. Like, you enter the image attributes, your image attributes, you try to identify what are those most significant attributes which will keep my image closer to the clicked image as much as possible. You identify those attributes, and then you try to create an output layer. So your resolution of your output image would be lesser than input image, but again it will like keep the most significant features intact. And that is how image compression occurs. And as I said, that algorithms keep on building. There was an easier algorithm, and it is again widely used right now as well, is clustering for image compression. So when I say clustering, what happens is that, so again, going back to my example, you have 100, say, different images, you have their attributes, etc. It tries to identify what is that segment, like what are the different segment of images, like, okay, these particular image belong to a particular segment because the primary color they have used is green, so that becomes one segment, and then blue becomes one other segment, etc. So you create all those segments, and imagine you have a image of, say, of 1,000 colors, right? So there are 10,000 different colors in different images, etc., and you create a cluster out of it. Then what you do is you find the center of those clusters, and each of your output image will be built using, so if my color falls in certain cluster, I will find the center of the cluster and put that color into my image. So your 1,000 color image might be reduced to say 10, 12 colored image. Again, keeping the, the overall quality of the image almost intact, but it will reduce the size of the image. Some resolution might be reduced, and obviously there will be errors as well. So yeah, so that is the last slide I had to cover. And I would suggest, to people who are trying to, develop their career in AI, to keep abreast of the things which are happening. Like, as I said, that every year there is a new technology, there is new things to learn in this field, etc. And it's pretty exciting for everyone who has been working in this field for long. So keep abreast of the technological changes which might be happening, and try to learn, give some amount of self time to learn those techniques. And obviously there are training courses which are available, and Transorg has also planned one, which can be a good, starting point for anyone who is trying to learn analytics. So I will take a pause here, and I will, if you have any questions, you can ask me. I'm trying to unmute you all. Or you can write also. I think there is a chat box where you can write your questions.
Hi, Rahul, can you hear me? This is Amit.
Yeah, Amit, I can hear you.
So there's one question by Rajiv Rai. He's asking, what is the trade-off between privacy and life experience enhancement? Is there any golden balance that can be arrived at?
So yeah, see, I didn't build this presentation to answer that. My presentation was that AI will grow inevitably. There are concerns around privacy, right? There have been concerns around privacy with how AI might be using at some point of time your personal information, etc. But still, the gains that are being made out of it, right? The kind of user experience that is getting created on applications. I might be wrong as well, but it might be, the gains might be higher than the losses that we might be making at this point of time. And when I say losses, if you are, say, educated, college graduate, it is difficult to commit a fraud on you. So your personal information might be belonging to different organization, but if you see at the frauds that are happening, they might not be happening at that scale. So people with a good intent in their mind are actually creating solutions using AI till this point of time. It might change in future, but again, there are also ways and means to control that, etc. Any other question? Okay, so no other question, then I will end this webinar. And so you must have received an email ID, and you can shoot your question to that email ID, and we will try to answer you back on that. So thank you all for attending this webinar. It was, I mean, I also learned a lot from it, because we keep on revisiting things which happen in AI and try to inculcate that. So thanks a lot. Thanks for your time.